Section 1.1, identify points, lines, and planes. So you can see from the learning targets here that these are things that you are probably already familiar with. But today we're going to take a look at some of their formal definitions. And I'd like you to kind of read through the list, pause the video, and see if you can think of a way to describe and identify and possibly even draw a picture of something you're familiar with of a point, a line, a plane, a segment, and a ray. So points are like dots, and we could think about a point as a star in the night sky. You see up there, you just see a dot, okay? A line you can think of because it extends infinitely in both directions as you look down a railroad track. Planes, I think about them as like a piece of paper, but it's like flat, but the difference is it's going to extend infinitely in all directions. A line segment is just part of a line. So if you take like where you park your vehicle, there are lines that guide you in there. Those are segments. Because they're only part of a line, they don't keep going. An array, I think about a ray of sunshine. It comes from the sun. It has a starting point at the sun, and it continues infinitely down to earth and beyond. So let's take a look at the formal definitions of some of these terms that we just gave you some examples of. First of all, a lot of the terms are called undefined terms. Undefined terms are words that have no formal definitions. So a point is an undefined term. It doesn't really have a formal definition, but there is an agreement about what they mean. So for points are named by dots. Points are shown by dots and they're named by capital letters. So the one that I have here is point A. But points also don't have a dimension. So if I make this point sort of bigger and thicker, we wouldn't say that it is larger than A. It is not. They have no dimension. So point A, point B, that's how we show them and we name them with a capital letter. Lines have no thickness. Again, they don't have a dimension, but they are straight. So lines are straight. That's kind of an important piece. And they have arrows on each end. That's how we write them. And they extend forever in both directions. Lines are named by 2 points with the line symbol above it. So this might be a little bit hard to see, but that line symbol has 2 arrows at the end. We can also name the line by a single letter that is a point not on the line. So this line example here could be line L, because we have this scripted L over here in the corner, so we can name that one line L. Otherwise, we can name it line AB or BA. It just has to make sure that the letters have to be points on the line, and doesn't matter the order. A plane is a flat surface that extends infinitely in all directions. So again, this plane keeps extending. And so we would name that plane by 3 points that are on the plane. Or again, if we have this scripted letter that is not a point, okay, we could also name it with one single letter. That is not a point. That's the scripted plane R. Otherwise, we could name it plane ABC. But again, the order of the letters doesn't matter. We could also name it plane ADC or plane CBA. It doesn't matter. We don't have a symbol for plane, so you need to write the word plane. Collinear points. Okay, it kind of describes itself. Co meaning next to each other, or like co-captains, they're together. So collinear are points that can be contained by a single line. So we could say that points A and B are collinear. Points B and C right here are collinear. So A and B are collinear. B and C, A and C, they're also collinear. But over here, these points can't be contained in a single line, so these are not collinear points. Now, you have to understand that any 2 points actually can form a line. So when we talk about collinear points, we're usually talking about 3 points, because you could have these 2 points right here. Those 2 could be collinear because they're contained in a single line. So that's why when we talk about collinear points, we're usually referring to 3 points. And similarly, coplanar points are 3 non-collinear points that can be contained by a single plane. So if we look at these points in this plane, we can say that points A and B and D are coplanar. Because they all are, here's A, here's D, and here's B. They are all contained in that same plane. Now, if I add an additional point out here, outside that plane, point E, now I could say that points C, D, and E are not coplanar, because E is not in the same plane. Now, even though the plane extends infinitely in this direction, that doesn't mean that E is in that plane, because it could be behind it or in front of the plane as it's extending. So let's get to some defined terms. Defined terms are terms that can be described using undefined terms. So what's weird is we describe and define terms using undefined terms. So we have a segment or a line segment, and that's probably something you're pretty familiar with. It's just part of a line that begins at one point and ends at another. So these are the endpoints of the segment A and B, but it's part of this line that it keeps extending. A segment is named by its endpoints, so we would name this segment AB. And the symbol that goes over the top is similar to what you have for a line, but there's no arrows on it. And you can name it in any order. So you could name this segment AB, or you could name this segment BA. But don't forget the difference in the symbols. Okay, make sure you pay attention to which symbol you're using and that you're using the correct symbol. Array is a part of a line that starts at one point and extends infinitely in the other direction. So here's our starting point, and this is ray A, B. And rays are named by its endpoint and another point on the ray with the ray symbol over the letters. And here order does matter, because the endpoint has to be the endpoint here. So we would name this ray AB. And so the order matters of the letters. We would not name this BA, because B is not the endpoint. So this one does not work. Opposite rays. If point B is on line AC, and it's between points A and C, then BA, and BC are opposite rays. So they're going in opposite directions. If I put another point on this line, however, so we could say that BA, we already said that, I'm sorry, BA and BC are opposite rays, because they both start at B and they go in opposite directions. But if I add point D here on the line. Now, if we look at BA, so now when we look at ray BA, and if we look at ray BD, they are not opposite rays, because you can see BA is in yellow and BD is not going in the opposite direction. So a lot of these things, it's good to think about what it is, but also what would be a counterexample or something that would not fit the definition. Intersections. Two or more geometric figures intersect if they have one or more points in common. So the intersection of two lines right here is always going to be a point. So line AP and line BP intersect at point P. Planes, the intersection of two planes is a line. So you can see we have two planes right here. We have plane P and we have plane Q, and they intersect at line AB. So it's a lot of definitions and terms, but these are foundational to geometry in general. So we need to make sure you understand those definitions and how to identify each of those terms, whether it's defined or undefined. So let's see if you can practice some of these things. See if you can name a line in that figure and then give 3 other names for that line. I'm not sure why this got a little blurry here, but we're going to name a line in the figure and 3 other names for the line. So we could name this line right here. We could name it line M, but we also see that there's a point A and a B and a C on that line. So we could also name it AB, or we could switch the letters, BA. But there's many, many other ones. You could name it AC or CA. You could also name it BC or CB. So you have lots of names for that one line depending on how many points there are on it. Name a point on line M. So we actually already identified those points. So you have point B or point A or point C. Not point M, because M is not a point on the line. You can kind of tell that because there's no dot there. Name the intersections of lines M and N. So the intersection of two lines is always a point. So it is point A. Moving on. See if you can try these 3 with what you know so far. Okay, so let's see what you came up with. Name the intersections of planes P and Z. So the intersection of two planes will always be a line. So we could name that. We could name that with that scripted letter at the end. So line L. Or you could name it line MV or VM. Name a line in plane R. Well, here is your R right here. Here is R right there. So all we need to do is name a line, and this line is still, that pink line is still part of plane R, because plane R goes all the way up here, and that line is part of it. So it's the same things we named above. We can name it line L, or we can name it line MV, or we can name it VM. Name a point in plane P. So plane P is this one over here. It's the blue one. And a point in that plane would be point M. And actually point V, because that line has to be part of plane P and plane RZ, or R or Z. So we could also name point V. So even it looks like this isn't part of that blue plane, remember that blue plane extends in all directions. So it continues going. And so that's why that point is part of the plane. One more example. Get a little trickier here, so see what you can do with these 3 questions. So let's take a look at these. It says name the intersection of line N and AI. So line N right here and line AI is, or that's a ray, excuse me, ray AI. What would be the intersection of those two? It would be this point. Point A. And you don't have to write the word point. Capital letters signify that it is a point. Name the intersection of planes Q and MPT. So, plane Q is this plane right here, and plane MPT would be this plane right here. And so the intersection of those is this line here. So you can name that with that scripted letter, line M, or you could name it with these 2 points. You have M and P, or vice versa. And then name 3 coplanar points in the figure. Well, in this, some of these colors start to look the same. In this plane right here that we were just describing, we have T, M, and P are coplanar points. So T, whoops, let me go back and get back to my colors here. So we could name point T and M and P. So these points right here, T, P, and M, are all in that plane. Okay, you could name, you could also use points in plane Q that we've highlighted, and we could name P, M, and R. Those would be parts of plane Q. These are from plane Q. And these are from plane MPT. And you could also look, I don't think we have enough points to name. Oh yes, we probably do, that last plane as well. But so that is the first section, 1.1.